So, organic chem must contain carbon. Write that down. The molecule, the substance must contain carbon. Water is not organic. Must contain carbon.
Why?
So why? Silas? Because that's the definition of the word organic. Organic chemistry is the study of all molecules containing carbon. Someone a long time ago said, let's call that organic chemistry. And the rest of us said, okay.
Why?
So inorganic chemistry. Okay, you know what? I have a better answer. That was kind of a lame answer. I'll give you a better answer. All living things have carbon. Everything on Earth is a carbon-based life form. That's where that term ultimately came from. And that's why carbon is considered organic. Inorganic is like rocks and dirt.
You have plastic is a
Yeah, plastic.
You're right. You're right. You're right. As with all things, basically in this class and science in general, there's gray areas and things that don't always make perfect sense. That's one of them. Plus, I'd be willing to bet, I don't know the history, but when this first became a thing, plastic probably didn't exist yet. I would guarantee it. So, must contain carbon. So that is this is an enormous part of chemistry. It's only one section though. It's a full year in college, 2 semesters, and that's a lot. There's a lot. I have an organic book over there.
I see it.
You do? It's really thick. It has like 1,500 pages in it.
Pretty thick. On the bottom shelf, next to the Chang chemistry.
He said chain.
Oh, I'll see.
This is it. 4th edition. They're probably on 10th edition. So this has about 1,300 pages in it, and it's all organic chemistry. And here, I'll just show you some stuff that looks wild. There you go. Let's see.
No way.
Kind of crazy stuff going on there. You get into like geometry and shapes and not just, this stuff. So it's pretty complex. I liked it. It's hard. You have to study and study and study and study and memorize and memorize and memorize. The more you can memorize, the easier organic's going to be in college. Here it's kind of the same, except you have tables P, Q, and if you flip it real quick, R. What are you doing, Shane? You with me now?
Yeah.
Good.
It's on his phone.
Tables P, Q, and speaking of the guy and his phone on this table. Table R. Table R also helps. So you have less to memorize than like college. But anyways, the point is, this is a huge part of chemistry. There's hundreds of thousands of these molecules. We're going to just talk about the simple ones. So, if you go to table P and Q, P tells us what?
Number of carbon atoms.
The number of carbon atoms, and then the prefix that goes with the name of that. So,
Meth is 1.
right. I'm going to go through and make sure you know how to say these things. So, a substance with 1 carbon, that's this right here. 1 black. Black one is carbon. Yellow ones are hydrogen. So, 1 black atom, this is meth. If there's 2 of them, what's the prefix? F. This is some weird dog somebody made, but it has 3, so it would be pro. We say pro. Pro. What if it has 4?
But
But is but. It's but. All right.
What?
So
E.
it's but. That's how we say it. But.
But.
And then if it's 5, it's pent, then hex, then hept, then oct, then non, then dec. Really? Do I care
Look what I
necessarily? Oh yeah, she made
That's cool.
what is that? Heptene?
Yeah, hemtine.
If we say
Yeah.
protein,
I think she's gonna. When we get back from break, you're gonna probably have to end up teaching because
Teaching?
seems like this is your thing. You're gonna be good at it. Anyways, so I don't really care if you say it wrong personally, but it's just better if you say it right. So don't say propene or propane. It's propane. You've heard of propane, right?
Butane.
Sorry, I haven't heard of propane yet.
Butane, not butane, right?
Butane.
Okay. Yeah,
Butane.
butane. Yeah, it sounds
Butane.
like some weird thing
Sounds
that
like
I
a
don't want to talk
disease.
about. It does actually. All right, stay with me. So, that was funny. So let's start off with what's the most simple structure that exists. What's the simplest organic structure? And this is it right here.
carbon.
Now, why is it this? So let's write this down.
Why?
Hold on. I'll come back to that. I'll come back. How many dots does carbon have? 4. I want you to write this in your notes. The electron configurations 2-4, 1, 2, 3, 4. How many bonds can it make?
4.
Yeah, and actually I'm going to reword that. It isn't how many it can make, it's, Mr. Decker did a good job saying this over and over, I heard him. It's not how many you can make, it's
How many it does it?
how many it must or does, right? It must have 4 bonds. There's no other option for carbon. That's it. It is what every carbon substance in the world, carbon's bonded 4 times. So it makes 4 bonds. And it has to have 4 bonds because it has 4 dots. That's it. There's no in between. So if I take 4 hydrogens and I stick them, bond them on those 4 dots, it looks like this. So that would be CH4. I don't know why I drew my H's to the side there, sorry. CH4. And that's it. That's the simplest structure that possibly can exist and be called organic.
Why isn't it just a carbon atom? Is that not organic?
Yeah, okay, fair enough. That's not a molecule though. So yeah, diamond, graphite, buckyball, that's all like a bunch of, millions of these things. You're right, that's good.
I'm just about to.
And that's an organic substance. So you know what? I guess what I was saying isn't right. I was thinking molecule the whole time. So, but that's a good point. So simplest molecule is this one. And Veronica, what's that called?
What's what called?
CH4. What's it called? Yes, you do. You're the expert. Not that's it.
I'm
I
not the
labeled you the
expert.
organic expert, so it's all over now. Next 2-3 weeks, it's all you. How many? All right. So we're gonna make her answer this, but everyone's doing this together. Now, first thing, let me back up, and then we'll move forward again. This has C and H in it. Go to table Q. Guess what this thing is called? CH4 is one example of a. It's an alkane, but look at the title of the chart. Good. What's the title of the chart? Homologous hydrocarbon.
Yeah.
Okay? So, before I get back to her and how to name this, even though Silas just said it, before we get back to that, I want you to write in your notes what a hydrocarbon is. A hydrocarbon is an organic substance, an organic molecule that only has C's and H's. So, a molecule with only C's and H's. You don't really need to memorize that because table Q is right there for you. But you will. We talk about this so much, you're just going to remember it. Hydrocarbons don't have oxygen, like sugar. Sugar is CHO. C12H22O11. It's organic, but it has oxygen in it. Not a hydrocarbon. Hydrocarbons only have C's and H's. They're the most simple structures. We're going to start learning that first. After break, we get more complicated. Yeah.
Aren't they all flammable?
Yeah, basically, not all organics, but all hydrocarbons are basically fuel. When you get oil out of the ground, there's like thousands of hydrocarbons in that oil, and you have to separate it so that you can get gasoline or propane or butane or whatever. Yeah, yep, yeah.
Can you pronounce all the name of those molecules? Ethane.
Yeah, I'm gonna get to that. But okay, I'll do it now. So alkane is how you say the first one. Alkene is how you say the next one, and alkyne is how you say the third one. Yeah. All right. So hydrocarbons are the simplest structures. They don't have oxygen. That's common in nitrogen. Hydrogen, oxygen, and nitrogen are the common ones with carbon in organic. But technically, any element up there can be in an organic structure as long as carbon's there. Okay. So back to Denotica. What's the name of this thing? Methane. Now let's talk about why. All right. If you go to the prefixes, you say, all right, CH4. How do I name this? Well, I see one carbon. What's the prefix? Meth. So this meth is because there's only one C. Now the ending is going to be ane, ene, or ine. That's it. So methane, methene, or methine. Now methene and methine can't exist. I'll talk about that in a second. But why is this ane? There's 2 reasons. The single bond thing and the way I teach it, I teach both. The general formula. Go to the general formula on table Q. If carbon is 1, so N is 1, how many H's do you get using the alkane formula? You get 4. Now plug 1 in for the other 2 formulas. You won't get 4 H's. Are you guys following me?
Yep.
Therefore, this CH4 cannot be an alkene or alkyne. It doesn't fit their formula. It does fit the alkane. That's why it ends with A-N-E. Methane. Yes.
So if there was like a, it was like C.
Hold on. Let me write it down.
Okay.
I think I know where you're going with it. So give me how many carbons you want?
Say 4.
All right.
C4.
C4,
H4.
H. Well, hold on.
H5.
Can I do that part?
Yeah. sure.
Okay.
Cool.
So let's say it's C4H8, and I want you to name that. You're kind of getting ahead. This is where I'm going in notes anyway, so we can just do it. So how would we name this? That's what you're asking, right?
Yeah.
Okay, so first thing you do is you look at the 4, and what's the prefix?
Butte.
Butte. So there's butte. Now, hold on, don't say it. Go to the general formulas. Only one of the 3 formulas will give you 8 hydrogens when you plug 4 in for N.
That's butte.
Yeah, the ene, right?
Yeah.
So it's butene. It ends in E-N-E.
Butene.
Butene, that's how you say it. Butene.
Do we use most of these? Like, I know.
Like in
Is it
normal life,
propane?
everyday life, no. A lot of this stuff is in organic labs or chemical companies that create things like
And-
shampoo and stuff like that.
So
Like
you-
it's in the process of making products. Soap is another one, you know. So no, not like regular people, but in industrial chemistry, yeah, a lot of it's used.
So if it was like H, say 10, would it be AIM?
Yes,
That-
it would be butane. Yes. So C4H10 would be butane. It would be ANE because it's an alkane.
And then H.
Oh, hold on a second.
So a single carbon atom would be an alkyne because it'd be C1 and then each it'd be 2 times 1. is 2
So a
minus
single
2.
carbon atom doesn't have a hydrogen, so it's not a hydrocarbon.
Oh, okay.
You need at least one H, and that's impossible because it has to have a minimum of 4
Okay.
if it's one carbon. So if it's just carbon and no hydrogens, then it's just carbon.
Okay.
It's not a alkane, or it's not a hydrocarbon. Does that
Okay.
make sense?
Yes.
Are most of these, when they occur naturally, anes?
Yeah, alkanes are more common. Yep.
Like butane, methane,
Well,
propane?
I want to say yes. I actually don't know for sure, but I want to say yes. That makes sense to me.
Like the stuff in lighters,
Yeah.
it's all like.
But it all comes from oil, which comes from the ground, and you have to kind of process that to
Did
separate.
humans make it into ane?
Well, yes, we can, and that depends. It depends on. So some of these hydrocarbons exist naturally in crude oil, but some we have to manufacture. So you take this hydrocarbon and this hydrocarbon, you like add it together, do a reaction synthesis, and you get this one. So some natural, some aren't. I don't know. There's so many combinations. I don't know. But yeah, a lot of these are natural. Yes. All right. So in your notes, I want you to do this: alkene, alkene, alkyne. So put all 3 right in the notes. We're gonna just take a little bit of notes under each one, and that'll be it here. Alkane. First of all, big thing to remember: all single bonds. You're gonna see this in lab. You've already seen it if you had lab with Mr. Dell. Alkene, you have 1 double bond, and that's where we use the springs. And then alkyne, you have 1 triple bond. And Tyler, I know I didn't get back to you, but we're gonna do right now, I think, what you're asking. So this here has the double bond because there's 2 springs. This would be Fe because there's a double bond, and then this one has the triple bond, 3 springs, so that would be my Fine. So what I want to do is just get one example of each one here. So let's say, bless you.
Thank you.
So for the single bond here, let's go with C3H8, double bond, we're going to go C4, well Tyler just did that one. So we'll go C5H10, and then this one will go C3H4. So what we would do is we would go to tables P and Q, and again, how do we name this? And in lab, we're going to learn how to draw them using the models. But right now, we're just going to do just more of what we just practiced. So we look up 3. 3 is pro, and then it's propane, obviously, because I put it under the alkane. Anes end in, or alkanes end in ane. Alkene ends in ene, and alkyne ends in ine. But how would we know? Because CnH2n plus 2 If I plug 3 in here, it equals 8. So I know that matches. Here, what would the name be?
Pentene.
Pentene,
There you go.
bless you, because it matches CnH2n. 2 times 5 is 10. Over here, it would be propyne,
Yeah.
propyne,
I don't know.
and that's because it's CnH2n minus 2. That's right, we'll get the hang of it. But this formula, 3 times 2 is 6 minus 2 is 4, matches this. So I'm trying to show you that if you know the formula, you can use P and Q to answer a lot of different questions, but mostly how to name it. And then hopefully you can do it in reverse. We can get into that next week. If I give you propane, can you write C3H8? Questions? Any other questions?
I'm pretty all set.
All right, good. Yeah, so that's it for now. We're almost out of time anyway. And in lab, like I said, Decker's lab did it. We're gonna do it today. Where you're gonna practice drawing these things and using the kit. So, that's it.
That's CS.
That's
Oh.
the way. Is there anything in the